All right, day 11, block 2. So we're going to get a little bit more into box plots and histograms. Um, we're going to look at mostly how to do this by hand right now, and then in the next video we'll look at how to use the calculator. So we'll get started with a quick review of measures of central tendency. Um, this is just a fancy way of saying like where's the center of a set of data, where's the middle, and there's a few different ways we talk about the center of a set of data. So we have this example here, number of home runs hit by Mark McGwire during the 1986 to 2001 season. So this is how many home runs he hit, quantitative data. First, we're going to look at the mean. The mean is another way of saying the average, right? When you guys ask, like, what's the average score on our test, we're talking about the mean. The mean on the calculator, we'll look at later, is represented by x bar. Okay, that's the notation. And to find the mean, we add up all the numbers and then we divide by however many numbers there are. So to save some time, I already added up all of these numbers, 70 plus 65 plus 52 and so on. The sum of all of those numbers is 583, whoops. And there are 16 actual pieces of data here. When you divide those, our average is 36.44 home runs. Okay. The median is often referred to as the middle of the data set, the middle number. So what we have to do to find the median is put all the numbers in order. So all the pieces of data need to be in order from smallest to largest. Now you'll have time to practice on your own. It takes some time and you need to be careful and pay attention to detail. And as you go through, I would cross it off. So 3 is first, and then 9, and then another 9, right? And so on, so that you don't miss any. So I have the list already. So 3, 9, 9, then 22, 29, 32, 32 again, 33, 39, 39, 42, 49, 52, 58, 65, oops, and 70. Just trying to save us some time here. Once you have all of your data in order, then you're going to alternate crossing off from the beginning and the end, so till you get to the middle. You hopefully remember this from elementary school. It seems like a slow way to do it, but it works. We'll learn how to do it on our calculator as well. Okay, so what happens here is because we have 16 pieces of data, we have an even number of data points, we end up with 2 pieces of data in the middle. So to find the middle of those 2, we're then going to take the average of the 2 middle pieces. Okay, this will always happen if you have an even number of pieces of data. So 33 plus 39 equals 72. I'm taking the average of 2 pieces of data, so divided by 2. So the actual mean is 36. It's saying what's in the middle of these 2 pieces of data, 36. Okay. And then the mode is typically referred to as the most common. Mode most common. So which piece of data happens most frequently? There can be many modes or there could be no modes. So you can say none if they all happen only once. There's no most common. So for this one, the numbers that appear the most often would be 9, 32, and 39. Those each appeared twice. So they're all tied for happening the most often. Okay. So those are measures of central tendency. This is a typo here, so make sure you fix this. The second part we call measures of spread, not central tendency. Again, measures of spread. So how spread out is the data? Our range is our max minus the min. So in this case, our maximum home runs was 70 minus the minimum, which was 3, 67. So the range of the data is 67. IQR, we're going to talk about more in a second, so don't worry too much about what it means, but the way we calculate it is by doing what's called Q3 minus Q1. You might not have any idea what I'm talking about. We'll get there in literally 30 seconds. So we're going to look at that. We won't even do it for this set yet because we're going to calculate in a moment. Basically, it's the middle 50% of the data. So if I could, it's hard. I'm going to show you in a second. So we're going to look at a graph that helps us see this middle chunk of the data. Oops, sorry. All right, so IQR is directly related to box plots. So box plots is our first graph we're going to learn how to make. Okay, it represents the data set in what looks like a box. Sometimes it's called a box and whisker plot. It's created using what we call the 5-number summary. So we need 5 pieces of information in order to make a box plot. Okay, it's made up of, the actual box is made up of Q1, which is 25% of the data, our median, which covers 50% of the data, and Q3. You might not have any idea what I'm saying right now. You will get there in a second, which is 75% of the data. The whiskers are located at the minimum and maximum. Okay, so to give you an idea of what I'm talking about, it looks something like this. So here's the minimum. Q1 would be on this line, median would be on this line, Q3 would be here, and maximum. We're going to make one in a second. That's like a sketch of a box plot. Box, whiskers. Okay, so let's actually make one, put more context to all of this stuff. So we're going to create a box plot out of the data from Mark McGwire's home runs. So I'm going to pause the video and I'm going to rewrite those numbers in order here. So I want you to do that as well. Put the numbers in order. You can just copy them from above, smallest to biggest. Okay, I have my numbers in order. So if I want to create a box plot, I always have to find the 5-number summary. So let's write that off to the side. The 5-number summary is going to be our minimum, then Q1, then the median, then Q3, then the maximum. And we usually write them in this order. So we already found the median above. The median was 36, so we did that earlier by crossing off first and last. Now let's go, we also know the minimum, 3, and the maximum, 70, so those are easy. Q1 is what we call the middle of the lower half. So the halfway point was right here in between 33 and 39. That's where we found that 36, our median. So we call that the middle. Q1 is going to be basically the median of this lower portion. So what's the middle of just this first half? So I can find it the same way I did with the regular median, crossing out first and last, first and last, first and last. Now I have these two numbers. So I'm going to do 22 plus 29 over 2. Whoops, I'm sorry. 51 over 2. So Q1 is 25.5. Okay. Q3 is a similar idea. It's the middle of the upper half. First and last, first and last, first and last. And then again, I'm left with two numbers. 49 plus 52 divided by 2. I'm finding the average of those. So Q3 is 50.5. Okay. We're going to learn how to find this in our calculator, so you won't always have to do this by hand. You pretty much after this lesson, we won't really do it by hand very often. But let's use these 5 numbers to make our box plot. So you need to draw a straight line. And now we need to draw tick marks on this line to cover all of the data we have here, these 5 numbers. But you're not just going to put 3 and then 30 or 25.5 then 36. You need to count like in order, just like you would on a regular number line. So I know if I start at 0 and I count, let's say by 5s, I should be able to cover all the numbers I need. So this would be 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, and then 75. So I have a little extra, no big deal. So I'm going to pause and fill in those numbers. You do the same. Okay, I have my numbers written out. You don't always have to start at 0 for a box plot. This one, it just works out because our minimum is so low, but you do need to have a consistent counting method. So either by 5s, 10s, 1s, 20s, like whatever works to cover all the numbers you have here. So now the box plot just kind of floats above this number line. So I'm going to put a dot for the minimum, and we're estimating it's about here. 3, put the number on top. Oops, sorry. For Q1, I put a vertical little line. So 25.5 would be right about here. I put the number on top so I know what that really should be. The median, I put a vertical line. The Q3, I put a vertical line. And then the max gets a dot. Now, if you put a vertical line for all of them, it's really fine. This is just most common, but it's not a big deal. But the important part is where the box goes. So the box only covers Q1, median, and Q3. And then what we call the whiskers goes out to the minimum and the maximum. Here's our box plot. Okay, this blue chart. But you do need the number line to kind of give that, like, to contextualize it. Where are those numbers actually, okay? So I think on the next slide here, the next page, you're going to create your own. Yep. So you're going to create a box plot for the temperatures in Chicago for 10 days. So there's only 10 pieces of data. Put them in order. Find your 5-number summary. So I'll remind you here first. So you need your minimum, Q1, your median, Q3, and your max. Okay, if you need to go back and look at what we just did, definitely do that, and then draw your box plot as well. All right, so here's my finished box plot. So I found my minimum, median, and max first because those are really easy. And then once I found the median, I kind of drew it in, or just like the vertical line. Since the two middle numbers are both 15, you don't really have to calculate the average. The median just is 15. And then I found the median of the lower half and the median of the upper half to get Q1 and Q3. Plotted all of them. This time I counted by 2s. Again, you have to have an even counting system down here to cover all the data. And then here's my box plot. Okay. This video, we're actually going to split it into 2 parts. So there's only one last thing we'll talk about here, and then that'll be the end of this first section. So the last one's pretty simple. We're going to look at outliers. So outliers are data points that do not fit with the rest of the data. It's either too high or too low compared to the rest of the data, right? We kind of know what outliers are. You're thinking like super, super tall people. Those would be outliers if you looked at a set of heights. So these 2 images here, they're box plots, but they're what we call modified box plots. And we'll learn more about those a little bit later on, because they show the outliers. You can make a regular box plot that doesn't show the outliers and has them just included, but these ones show us where those are. So the outliers, pretty easy. They're the little dots that are hanging outside of the box plot. So here's our minimum, Q1, median, Q3. Our maximum is over here, but this maximum is not really the maximum of the entire data set. It would actually be our 2 outliers that we circled, but we'll learn how to make this modified box plot show that. Okay, same thing here. These are the actual minimums, but this is where our box plot starts. Okay, and yeah, so that's the end of this first part. The next one we'll talk about histograms, so we'll make a separate video for that.